Hi students, I hope everybody is doing fine. So today under the chapter work and energy, we are going to discuss the work energy theorem. We have done this earlier as well, but let's try it again. And work energy theorem is nothing but basically how work and energy related. Okay, how there is mathematical relationship between that is what we are going to find out. So the work energy theorem, basically what it states that the net work done on an object by all the forces acting on it is equal to its change in its kinetic energy. Okay, so sorry. Okay, hello, hello. Okay, I'm starting again. I got distracted by that voice.
Hello.
Yeah,
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 ma'am.
hi.
So sorry, my internet was gone. So because of that, the connection was lost, ma'am.
Okay, I'm starting again then. Okay,
Start topic, you're starting again, ma'am.
yeah, yeah.
Have you continued or you also leave the meeting, ma'am? Left the meeting?
Sorry. I didn't get you. Now only it happened, right? Or it was from a
Yeah,
long
yeah.
time?
Now only it happened.
No, I didn't leave the meeting, but I stopped teaching because I got that ting sound. So, and
Oh,
then,
okay, okay. So
then
sorry
my,
for the inconvenience. The once the power gone, no, the internet, everything will gone immediately. So I'm
okay,
reconnecting. It's not taking, ma'am. If that is the case, you can continue the class, ma'am. It will not
okay.
provide any problem.
Yeah, because my face was not being shown. Then I thought maybe
Oh,
you
okay,
left.
okay. So sorry for the inconvenience.
So it's okay.
Okay, ma'am.
So then I was like, I thought maybe something
Yes,
is
ma'am,
wrong.
please.
That's
Yes, yes.
why I am starting again. Okay.
Okay, ma'am. Thank you.
Okay, no problem. Yeah, okay. Hello, students. Welcome back to yet another topic of work and energy. Here we'll discuss about how work and energy, they are related in a mathematical way, or what is the relationship among these two. So what exactly would be, this? Let's talk about that. So the net work done on an object by all the forces acting on it is equal to the change in its kinetic energy. What do we mean by that? Is basically the work done, okay, the net work done or total work done on any object by all the forces acting on it, okay, from any direction or everything, is going to be equal to the change in its kinetic energy, that how much change it has seen. Okay, so for example, we can write work done is equals to delta ke. That means nothing but whatever the final kinetic energy has been achieved. No, okay, let me just remove this. Okay, so the final kinetic energy achieved minus, because it's going to be change in its kinetic energy. So it changed, right? So it reached from a point A to point B. So that means the final minus the initial. Okay, now when work done is positive, the object gains kinetic energy and speeds up. Okay, so if work done is positive, that means final minus initial is going to be positive, and that means the work will speed up. Okay, the object will speed up. When work done is negative, that means the object loses its kinetic energy and slows down. So if W is equals to negative, okay, so that means it's losing kinetic energy and the work is going to slow down. And when the work done is, zero, the object's kinetic energy remains constant. It won't change. Okay. So that is what we mean by that. Okay. So derivation of work energy. So this we have already done, but let's do it one more time so that you can, remember it forever. Okay. So let's take the first step. Let's start with the force. So force is equals to ma, that is mass into acceleration, right? Now we know that we know that work is equals to fd. If we talk about work done, okay, fd, and cos theta, that we don't have to take right now. So let's talk about force. So if we put the value of force, it is nothing but this, from first equation we can take as ma and then d. So this, if you can't remember, you can go back to, into the chapter of motion, gravitation and all, okay, and sorry, forces, okay, that chapter, and you can check it there. Now let's go to motion. Okay, so in motion, you have seen an equation v square minus u square is equal to 2AD. So from here, you can calculate the distance as, or sorry, the displacement as d is equals to v square minus u square upon 2a. So let's put the value of d in the next step. Okay, so let's take ma into v square minus u square upon 2a. Okay, now a and a will be cancelled here. Okay, now what are we getting? We are getting, you can say 1 by 2m v square minus u square. That is what we are getting here at this stage, right? Now we know, since we know that, u is going to be 0, because when we are starting, it is going to be 0, right? The object in a certain position, which is not moving, is going to be 0. So initial, movement would be 0. Okay, so we can write it as half mv square, and that is going to be kinetic energy. Okay, so now work done is equals to nothing but kinetic energy final minus kinetic energy initial. Okay, that is nothing but delta Ke. This is delta, pronounced as delta. Okay, so this derivation shows nothing but the work directly relates to the change in the kinetic energy. Okay, so this is the derivation. You should know this. Okay, now these are few examples. So an object is being taken of 5 kg of mass. Okay, so mass is 5 kg, accelerates from 2 meter per second to 6 meter per second. So you are given with the final, or final velocity and initial velocity. Initial velocity is accelerates from 2 meter. So initial is 2 to final, that is 6, right? You will put the value and you will get the work done like this. Now, since it has come in positive, manner, you can say that object gains kinetic energy and it is going to speed up. Okay, right? Now here 0 work example. So if net work, done is on an object, sorry, if no net work is done on an object, what happens to its speed? So work done is equals to delta Ke. Now delta K is 0. So Ke is equals to Ke final is equals to going to be Ke, initial, right? So the kinetic energy, remains constant here, which means the speed stays the same and not going to move, or the object is not going to move with a high speed now. So this explains why object in space continue moving at a constant velocity. Okay, right? Okay. Now, so positive and negative work done, we already discussed that. Again, let's just quickly see it. So positive work done is like pushing a car. So energy is being, transferred in the direction of the object only, where the moment is, right? And negative work done is transferred from the object. Energy is being transferred. So friction slowing down a sliding box, brake stopping a car. All this is a result of, you can say, negative work. Here, the kinetic energy decreases. In positive work, the kinetic energy increases. Okay. Then, driving a car. So the engine does the positive work here, and it is converting chemical, energy into kinetic energy. And that's why when you are pressing the accelerator, the car will speed because its kinetic energy is increasing. In roller coasters, we have already discussed that gravity does positive work and converts the potential energy into kinetic energy, which is like helping the roller coaster move down. Okay, and throwing a ball. So when you throw a ball upward, gravity does negative work converting the kinetic energy into potential energy until the ball reaches a maximum height. Okay, a maximum position, and then from there it falls down. Okay, so now, okay, some answers are given. The question 2 you have to solve. So the state the work energy theorem. So here you can tell that the net work done on a body is equal to the change in the kinetic energy, okay, of it. Okay, now a 2 kg body accelerates from 3 meter per second to 7 meter per second. Find the work done. This you can do by calculating the final kinetic energy and initial kinetic energy, right? And you can, or maybe you can simply do by the formula which I have given you earlier. Now, if no work is done on a body, what happens to its kinetic energy? It remains constant. That means kinetic energy final will be equal to initial. Okay, this is why the object in space continues to be in a constant motion. And a ball is thrown upward. What kind of work does gravity do on it? Obviously negative, because the object is moving upward and the force is being applied downward. So displacement is upward and this is down. So work will be negative, right? So some misconceptions are there. First is, let's burst those out. So first is work and force are same. No, it is not same. Work can be, first of all, work involves both force and displacement. So it has force and as well as displacement. And no movement means no work, even if there's force. Okay, so even if this force is there, displacement, there is no displacement, so no work will be there. Now, work is always positive. This is misconception which is there. Work is, you can say that I have done this much work and it is very positive, right? But in physics, work done can be, negative if the force being applied and the displacement both are in opposite direction of each other. And last is, all forces do work. Forces that are perpendicular to motion do zero work because the force is perpendicular to the displacement. This I have told you. For example, the object is moving, you are applying this side, the force on this side, but the object is moving this side. So there is a 90-degree angle. And what I told you about cos 90, that is nothing but zero, equal to zero, right? So when you will put the value in this formula of work done, okay, of 90 degrees, you will get force into distance into zero. And that will be work done is equals to zero. Okay, so now I think you are clear with this chapter. And thank you so much for joining the session. I hope you enjoyed and learned something new here. Okay, if you have any doubt, any query or any feedback, feel free to give it in the comment section, or just you can approach me on my Urban Pro profile and we can discuss it there. Thank you. Take care. Bye-bye.